The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Ladies and gentlemen, you're welcome to my class. My name is Dr. DrAvitech, and I'm going to be teaching, or I'm going to be showing you how to solve this very problem. Now, the first thing is, I want to graph this function. The thing is, sometimes you will notice that I graph, sometimes I won't graph. First of all, if my function is quadratic, a parabola, I won't graph, because that information will not help me with anything. Secondly, I graph when I notice that I'm dealing with a linear function, not just a linear function, but I deal with when one part is a negative of the other, I will go and graph. So, but sometimes I know that when I do that, it might not really be nice, but it helps me sometimes. So in this case, I'm going to be graphing because one is a negative of the other. Even though that this k is a constant, they didn't really give us a value. So I'm going to put my line here, and this should be minus pi, this should be 0, and this should be pi. Now let me put, because I said f of t is k, so this is the t-axis, and this is the f of t-axis. So let me put my minus k here, let me put my k here. Now they said f of t was minus k when t was at minus pi to 0. So from minus pi down to 0, the value was the same. From minus pi down to 0, the value was minus k. So I have something like this. Then from 0 to pi, the value was k. The value was k. Okay, this is not looking fine. Hold on. They are supposed to exactly look the same because they are the same distance from, yeah, it's supposed to look the same. So as you can see, this right here is perfectly looking like an odd function. It is an odd function. So I wouldn't really be stressing myself to solve this. So I have this here and I have this here. So what I'm going to do next is to find only b sub n, because this is an odd function. It's an odd function. It's symmetric with the origin. Or you could say that this is a 180-degree rotation of this. If I rotate this twice, if I rotate it first to this part, then I rotate it to this part, it's a 180-degree rotation. And also, if you watch the video of what I explained about even on odd functions are having the same exact graph on two opposite quadrants. So I'm only going to be finding b sub n. So b sub n is 1 over pi, integral from minus pi to pi of f of t sine nt dt. But again, since I am only looking for b sub n, I can take the half range of the whole function. I can take the half range because this and this are the same. So I can just do one part only. I can just take the half range. So by taking the half range, I need to multiply this by 2. So this is 2 over pi, integral from 0 to pi, f of t sine nt dt. So this will be 2 over pi. Remember to watch the video I made on even an odd function. Integral from 0 to pi, f of t is k. So this is then k sine nt dt. Now the k is a constant, so I can bring it out. So this will become 2k over pi, integral from 0 to pi of sine nt dt. Alright, so this is what I have. So this will become 2k all over pi. Now let's integrate. If you integrate sine, you will get minus cos. So this is minus cos nt over, divide by the derivative of nt. So that's n. And this is from 0 all the way to pi. Now, the minus is a constant, the n is a constant, so I'll bring out the 2. So this is minus 2k over n pi. And then we have it from, this is cos nt, from 0 to pi. Now what I'm going to do next is, anywhere I see t, I'm going to put pi. So this will become minus 2k over n pi into cos n pi minus cos 0. So I just evaluated the limits. That's what I just did. Just evaluated the limits. So this is minus 2k over n pi. Then cosine of n pi has a special value, and it's minus 1 to the power of n. Minus cos 0 has its own special value as 1. Now what you need to then remember is this bracket behaves in a particular way. It can be 0, or it can give you another number that is not 0. So let's kind of think. When n is odd, let's see what this will behave. So we have minus 1 to the power of n minus 1. This minus 1. Let's say n is 1, which is an odd number. Anything raised to the power of 1 is that same thing. So we have minus 1 will be here, and then this very minus 1. So this is minus 2. So when n is odd, this bracket is minus 2. So that means our b sub n is minus 2k all over n pi into this whole bracket is minus 2. So when you expand, you'll be getting minus 4k because minus is going to be plus. Minus 2 times minus 2 is plus. So that will be plus 2 times 2 is 4. So that's 4k over n pi. So this is your b sub n when n is odd. Next, when n is even. When n is even, our bracket is minus 1 to the power of n minus 1. So this is minus 1. This n you see here is 2. We're picking an even number, so we want to pick 2 because 2 is even. So minus 1 squared is 1 because when you square a number, you get positive. 1 minus 1 is 0. So what does this tell us? This tells us that this bracket will be 0, and 0 times this will give me 0. So it means that b sub n is equal to 0 when n is even. So just throw that one away. That's why I said sometimes it will be 0, sometimes it will be a number. So our Fourier series f of t will be equal to the sum from n equal to 1 to infinity of b sub n sine nt. Now, just sine nt. I wanted to go and put the t. Now, why did I not put a naught? Because there's no a naught. Why did I not put a sub n? There's no a sub n. So this will be the sum from n equal to 1 to infinity. Now, this expression here, b sub n, is 4k over n pi. And then sine nt. Now, what are the constant terms here? The summation is with respect to n. So this 4k over pi is a constant. So bring out 4k all over pi. Then put your sum from n equal to 1 to infinity of 1 over n. Because if the 4k goes, there ought to be a number at the top. So that number is 1 over the n, then sine nt. But here's the thing. Always remember that you said this would only occur when n is odd. So do not forget. You can put comma odd here so you do not forget. So that you do not forget. But I really do not do that. I will show you what I do. So this is f of t, this is f of t. So f of t, now let's expand this. We have 4k over pi, open up a bracket. Let's kind of bring out some harmonics. So let's n equal to 1. 1 over 1 is 1. Sine 1t is sine t. So this is sine t plus the next number will be 3 because we're only picking odd. So this will be 1 over 3 sine 3t. The next will be 5. We're only picking odd. So this is 1 over 5 sine 5t. 1 over 7 sine 7t. And just like that. So we can't really go far. We can't really go far. So that's what it's going to be. Now, what if you were told to leave your answer in terms of n? That is, you see this summation, don't expand it. So if that's the case, this will be 4k over pi with the sum from n equal to 1 to infinity of 1 over. Now, because this is always odd, all of your n, change all of your n to 2n minus 1. So this will be 1 over 2n minus 1 sine 2n minus 1t. When you do this, is still the same as this. Just that this time around, no matter the value you put for n, your answer will always be odd. No matter the value for, so you don't need to put n odd beside this. You don't need to put this odd beside. When you represent it like this, every single number you get here will always be odd. So that'll be all for this very video. I'll see you in the next one. Thanks for watching.